All right, lesson 310. We have been just diving into trigonometry left and right, left and right. And truthfully, we've done very little solving. It's been a long time since we've solved the problem. It's been with exponentials and logarithms since we actually used our math to solve something. That's what today's about, is how can I use this to solve something? Okay, so let's begin here. When we deal with trigonometric equations, we're frequently going to use the unit circle. I have posted here that when you deal with inverses, I want you to recall that our domain is going to look different. So if the domain on a normal trig function is the angle, those are going to be restricted that's going to be a restricted range when it comes to inverse trig. And I want you to recall that for sine and cosine, sine and tangent, will be from negative pi over 2 to pi over 2. And then for cosine, it goes from 0 to pi. So what I have here is what I call an inverse or modified unit circle to show you that. Now, really quick, skip to the very end of your packet. What do you have in your very last slide? A unit circle. So today, if you're solving and you're struggling with some of this, here's your unit circle to help you out. But with inverse trigonometry, if you're doing an inverse, will you use all those values? No. And that's what the point of this slide is, just to show you, hey, with inverse, you might not have all your values. Not everything's going to be within the domain. So that's the point of that slide there. All right, let's start here. It says, consider the equation sine x equals 1/2 on the interval. And I want to point out that this, when they give you this is an interval. I'm going to call this x1 and x2. What's not included here are y values. When I'm giving you an interval, it'll only be x values. So you're looking from negative 3 pi over 2. That's where this is. All the way to 7 pi over 2. That's where this is over here. Okay, that's the window to which we're looking. It says, notice when you graph and you're trying to solve, I have two different graphs here. What I have graphed is y equals sine x. That's this graph, the curved. Go ahead if you want to write that. Y equals sine x. That's the curved graph. And then I have also the graph y equals 1/2. Sorry, y equals 1/2. That's this other line. If you were going to take a graphical approach to this lesson, if we were allowed to just use calculators on every problem in the test, I could just show you, hey, we can solve these by graphing and looking for intersections. How many intersections do you happen to see between these two graphs as sine x and y equals 1/2? 1, 2, 3, 4, and 5. We'd have 5 solutions. So like it says, can you name what the 5 solutions are? Well, each of the 1/2 or each of the y values is 1/2. That never changes. So you would actually not list those if you're taking a graphical approach. But what you would change or what you would list are the x values. You would say, well, x equals. Now let's figure out, what are these counting by? If this is pi over 2 and it's divided into 3 sections, what's pi over 2 divided by 3 more to get each section?
Pi over 6.
Okay, that means this right here is 1 pi over 6. We're counting by pi over 6s. That would be 1 pi over 6.
2 pi over 6.
Yeah, and 2 pi over 6 could reduce to become 2 pi over 6 could become pi over 3. This would be 3 pi over 6.
Pi over 2.
That's right. This would be 4 pi over 6.
2 pi over 3.
You're following along now? This would be 5 pi over 6. That's right. And so on. Okay, so let's list out our answers. I'm going to start with this one right here. So this is -1, -2, -3, -4, -5, -6, -7 pi over 6. That's -7 pi over 6. Does that reduce? No. So that's our first answer. -7 pi over 6. Our next answer would be 1 pi over 6. What about this one? 5 pi over 6. We already have that. Okay, now let's jump ahead. So if this is 5 pi over 6, we have 6, 7, 8, 9, 10, 11, 12, 13. Does 13 pi over 6 reduce?
No.
And it does not. So it's 13 pi over 6. And now finally, 14, 15, 16, 17 pi over 6. Now, something else that's going to be important, if you're listing your answers on a certain interval, you'll only list the ones you see. So this is on the interval from -3 pi over 2 to 7 pi over 2. Let me go back up so you can see that. These are on that interval. All these are the answers on -3 pi over 2 to 7 pi over 2. But what if I wanted all solutions to the equation outside of the domain? Like if I just wanted all of them, what you would do is you would list any value, and then you would not really list its continuing repeated ones. You just list it one time with its period. So on this one, how many, I'll call it unique solutions, do we actually have of those 5 listed?
Unique solution?
Yeah, how many are kind of like just totally unique? Not the x values being unique, but on the wave,
No.
on a unique place on the wave.
Negatives.
2. The answer is 2. I have 2 that are unique. This one going as the function is on where it's concave down as we increase, and this one where we decrease. Those are the only 2 unique. These are repeats. It would be a repeat. So how would I list this? Here's how you do it. You would list them out as x equals, because that's what they are, x's. X equals pi over 6.
Would you just say?
And then how long until that one repeats? 13 pi over 6. Now, what do I need to add? 12 pi over 6. Can you reduce that?
2 pi.
2 pi. And so the way you would do this is they usually will use like a letter like k, and they're going to say 2k pi. That k represents any integer. You can do it as many times as you want. So if k is 1, it's the answer 1 to the right. If k was -1, it would be 1 to the left. So that would find all the pi over 6 answers that are increasing on its as sign increases going up towards its maximum. That would be that value. Now, what would get us as we decrease from the maximum? Well, you would take 5 pi over 6. And how often will this one repeat? We could look at it just to make sure. If at 5 pi over 6, when does it repeat? 17 pi over 6. How much did I have to add? 12 pi over 6, which is the same thing. 12 pi over 6 is the same thing as 2 pi. Throw a k in there, and that will give you all of them, meaning even outside the domain. This would be the formula for all answers. Okay, so this is for all answers. For all, how about I just for XER, for X, any value of the reals. And this is considering k has to be an integer. That means a whole number. We can't have a decimal of k, but k is only whole numbers, positive and negative. Okay, so that's a graphical approach. We're not going to spend much time doing the graphing. That's there for you. But I want to make sure you know how to do this using algebra as well. So that's example 1, just taking a graphical approach. Okay, let's move on. Whoops, did I go the wrong way? To example 2. Now we're going to use, we're going to solve using a algebraic approach. So graphing, you just graph the 2 sides of the equations, look where they intersect. Okay, now let's take a algebraic approach. So Gabby, what would you do first here? We're solving for x here. What would you do first to solve for x? We would subtract 1. So if I subtract 1, I have 2 cosine x equals -1. All right, Dulce, what would you do second? Divide by 2. Good. We would divide by 2. All right, Quintanilla, what would you do next? Again, we're trying to isolate the x, which we don't have it isolated yet. What would you do next? That's right. Actually, I'm going to pause for a second. We're going to do the inverse of cosine. I want to pause for a second. What I should do here is cosine is going to be -1/2. That's telling me where my answers will be on this unit circle. If x is going to be negative, if our cosine is negative, that means the x will be negative. Where do I have a -1/2? Well, on a unit circle, this is the point. Go ahead and label this. This is -1, 0. Where is the x -1/2? Well, exactly halfway in between. Our 2 answers are going to come when we have an x at -1/2. That's -1/2 right there. So we will have 2 answers here at these 2 locations. And I'm going to use a straight line to make sure I hit this right. We're gonna have an answer here. And we're gonna have an answer here. Why am I gonna have those two answers? Because at this location, what is my x value? -1/2. That's right there. Okay, so now Quintanilla is right. For solving's purposes, you would do an inverse. So x equals cosine inverse of -1/2. Okay, so let's still go to our hand trick. On our hand trick, if it says cosine inverse, are we looking at the palm of our hand or the back of our hand? Okay, look at the back of your hand. The 1 comes from a square root of 1. You need x to have, you need one x finger, a one's, am I saying this right? You need your x to be a square root of 1. So you need one x finger. Which one do I bend? So ring would give you one sine and 3 y's. 1 y, 3 x's. So which one am I bending to get one x index? This would have 3 y's, but all I care about is the cosine, which is 1. So you're bending your index. Flip your hand over. What type of angle creates? It's going to be a pi over 3. Our answers have to be pi over 3's. Now, let's go over here. Is this actually 1 pi over 3? Is this location 1 pi over 3?
No.
No, because this right here is pi over 2. So what pi over 3 is it if it's in the second quadrant?
5 pi over 3.
Let me actually go ahead and lay this. I hear 5 pi over 3. That's not right. That would be fourth quadrant. You're on your way to becoming 1 whole pi, but you're not there yet.
2 pi over 3.
It would be 2 pi over 3. Now over here, you're past 1 pi, but you're still in the third quadrant, which means you're closer to 1 pi, but you're past 1 whole pi.
5 pi over 3. 4 pi over 3.
4 pi over 3. By the way, 5 pi over 3 would be over here. 5 pi over 3 would be over here. 1 pi over 3 would be over here. So our two answers are 2 pi over 3 and 4 pi over 3. Those are our two answers. By the way, on the inverse, if you type that in the calculator, if our calculator was able to give you pi answers, the only answer it'd give you is 2 pi over 3. It would only give you this one. Why would the calculator not give you this answer down here? Because on inverse, it would restrict that out of there. Don't do that on your packet because you actually take both these answers. The calculator would restrict that out. It would not give you 4 pi over 3. It would only give you 2 pi over 3. But this one has both answers because did the original start with a restriction? The original had no restrictions, so you need to include both of them. All right, let's go on to part B, unless you have questions. You have questions? Then let's go to part B. Let's solve algebraically here. Ivan, what would you do first? Okay, he said subtract the square root of 2. Can we change that slightly?
Yeah.
We actually add that. Yep, add the square root of 2 to both sides. So I have 2 sine squared x equals square root 2. Now what?
Divide by 2.
We divide by 2. And I'm looking at this here. I'm going to have a problem in a second. This should not, as a typo, this should not be a squared yet. Go ahead and take away that square. I'm not ready to go to calculator yet. Take away that squared. Okay, so now where are we at? We are that sine x equals the square root of 2 over 2. Now, before we actually go any further, I'm going to pause for a second and come to our unit circle. What is this telling us about the sine? Or specifically, sine is what variable? Y. What at this time, now that we have the sine isolated, what can we tell about the y's? They are positive. Now the square root of 2 over 2. If you type that in the calculator, this point right here is 0, 1. The square root of 2 divided by 2. Square root of 2, I think it's like 1.41, something like that. If you divide that by 2, you're at approximately 0.7. So go find a spot where you think might be 0.7. Let's just call it right there. Let's say that is the square root of 2 over 2. We need to have 2 points that have that height. Here, we'll say that's y equals square root of 2 over 2. And we'll have another one over here. Now, I'm gonna go ahead and use a little tool here to make sure I have a straight line. I'm gonna go through both of these points. And then we'll pick up from here and solve using hand trick. Okay, so once I isolate the trig function, that's when I go to the unit circle. Okay, now let's solve this. How could I isolate this x here? You do the inverse of sine. So the inverse of sine of square root of 2 divided by 2. So hand trick, if it's doing inverse of sine, which side of the hand are we looking at? The back side of the hand. Look at the back side of your hand. You need 2 wide fingers. Dulce. Which finger am I bending?
Middle finger.
Middle finger. Bend your middle finger, flip it over. Now we're on the pi side of your hand. What pi is that? Pi over 4. Our answers are going to be some type of pi over 4s. So it's going to be some type of pi over 4s. Now let's look at our answer. Is this actually here pi over 4? All right. Is this over here actually pi over 4? No. What is it? Let's think about it. It's a pi over 4. It's approaching 1 pi, but it's not yet at 1 pi. So it'd be 3 pi over 4. That's right. We're not quite to 1 whole pi. So the answer would be 3 pi over 4. Now, one more time, I'm going to kind of go back to what I did a second ago. Don't do what I'm about to do on your packet. But over here, if you were just given this, if this was all you were given, would you have both answers?
No.
No. Because if you were given the inverse, you would restrict the left side of the graph, because you would only use the right side with sine. Sine doesn't have an x, you would ignore the negative x's. You just assume x's are positive. So you would cross that out. And again, the reason we cross that out in our last class is to make it be a function. It's the only way it would be a function. But that's what would happen. But this problem did not give us the inverse. That's why we're taking both answers, because it did not give us inverse. All right. So with that, let's go on to part C. And then we will do our first DOL. Increasing difficulty a little bit here.
Oh, God.
Hey, it's not that bad.
Oh, no.
What should we do?
All right, so we're going to find
Serenity, what do you think we should do first? She wants to add 5 to both sides. Okay, I'm fine with that. Let's add 5 to both sides. All right, so now I have 18 cosine x minus 2 equals 14 cosine x. What do you think we should do now? Nope. You could do that because it is multiplying, but there's another thing we can do.
You wanna do the inverse of cosine?
How about this? How about we subtract 18 cosine x? Because these are like terms. Now, I'm doing it this way just because we just moved the 5 over. Otherwise, we're going to move that 2 right back across. So when I subtract those cancel, they're opposites. And what I'm left with is negative 2 equals?
Negative 4 cosine x.
Okay, and so now what would we do?
Divide by negative.
Divide by negative 4. Good. When we divide by negative 4, we're left with, what's that become? 1/2 equals cosine x. Okay, I'm gonna pause here. Now that I have the trig function isolated, cosine deals with which variable? X. We need a positive x, and it needs to be 1/2. Again, here's 1. Here's the x value. Whoops, I did that backwards. 1, 0. So half is halfway. That would be 1/2. And so x equals 1/2 would be right here, which means it would be a line connecting these 2 points on the unit circle. So let's go ahead and add that in. There are 2 answers. Now we have 2 answers because this is not given as an inverse. If it was given as an inverse, we'd only have 1 answer. Okay, so now picking back up, let's solve the problem. How do I actually isolate this x?
The inverse of cosine.
That's right. And I'm going to rearrange it. So I'm going to do the inverse of cosine on this side. So it's inverse cosine of 1/2. So go to your hand trick. If it's an inverse cosine, which side of the hand are we looking at? Back side. Okay, on the back side of the hand, we need one cosine finger. One comes from the square root one, so I need one cosine finger. Which one do we bend? Index. Bend your index, flip it back over. What is your index?
I mean,
It's some type of pi over 3. So is pi over 3 this first one?
Yeah.
Yeah, it is. It's pi over 3. Did this say on an interval of 0 to 2 pi? Well, we could use negative pi over 3. I'm not. What would this be if we started at 0? This is 1 pi.
negative
This is 2 pi. Not negative. If you went all the way around, you'd call this
5 pi over 3.
5 pi over 3 because it's almost
It's almost
2 pi's. 2 times 3, the denominator would be 6. So 1 less than 6 is 5. Those are your answers. Pi over 3 and 5 pi over 3. That's your second answer. Now that you've seen me go through this a few times, I'm going to let you try this tangent. Remember, tangent is what ratio? It's going to be y over x. Yep. And tangent also, is tangent y's, is tangent x's, or is tangent going to appear like slope when you use the unit circle? It's going to be a straight line. Yep. So you're going to find your answers as a straight line. All right, go ahead. DOL number 1. All right. Let's look at example 3. Now we're going to do the same process, but this time we're going to have to use the calculator to get our values because they're not going to be hand trick values. Okay. So I'm just going to walk you through how to do it with the calculators. First, I want to make sure everybody's in the correct mode for doing this. We're going to do this in radians. So take your calculator, press home screen to menu C. Home screen to menu C, click OK, and it'll reset everyone's calculators and it'll put it into radians. I just want to make sure everybody's in radians for this. Your calculator needs to say RAD once they come back. Once they come back. Okay, so everybody should be in RAD mode. All right, so let's work our way through this and solve it again. What would we do first on example 3A? Add 5. So we add 5 to both sides. And I have tangent x equals 5. Now with tangent doesn't represent y's alone. It doesn't represent x alone. It's y over x, which is the same thing as slope. We have a line here with a slope of 5. What I'm going to do is I'm going to draw a line with a slope of 5. That means I go up 5 over 1. I think it's going to be somewhere in here. I would guess it looks something like that. So that's what my line should look like. Is something around like that. So I'm going to make sure I have a straight line here. I'm going to do it this way. There we go. So that's what my two answers are going to look like. All right, let's pick back up. How would I solve for x here? We're going to do the inverse of tangent. So we're going to go to the calculator and type in, hit the trig button, find tangent inverse of 5 and press enter. Today we're going to round to the nearest hundredth. What does that mean as far as decimals go if you have to round to the nearest hundredth?
Second, 2 decimal spots.
That's because 100 has 2 zeros and it's going off of the zeros. 100th would mean 2 decimals. So our 2 decimals, would it be 1.37 or 1.38? 1.37. Now that right there is the first quadrant answer. This value right here is 1.37 radians. 1.37. That's this answer up to here. That means 1.37 radiuses long to get from this point, standard position, up to here. Now let's talk about this answer. How would I get that? Well, if this from there to there is 1.37, from here to here, this is also 1.37. Tangent's the easiest for finding the second answer because, well, where does this line start from? It starts from pi. They're always pi apart. The two answers are always a straight line, which is like 180 degrees or pi radians. So they're always pi apart. To get my second answer, what I'm going to do is I'm going to type in pi plus 1.37. Pi plus, and to be exact, I'll just copy that previous answer. Pi plus that. That's my second answer. Now, what would that round to? 1.51 or 1.52? I'm sorry, I said 1. 4.51 or 4.52? 4.51. Those are our two answers. So the two answers we have here are 1.37. And let me do rounded. The approximately symbol is X with a squiggly equal sign. And then 4.51. Those would be our two answers here. Now, how did I get those two answers? Again, they're pi units apart. That's a straight line is pi. So you just add pi to the previous answer to get the second. All right, let's reload and do part B. First step up, how do I isolate this cosine? I'm trying to isolate x. I need to first isolate cosine. How do I do that? Divide by 5. So cosine x equals 3/5. I'm going to pause for a moment. Now, on a unit circle, that value right there is 1, 0. That means the x-axis goes has a maximum at 1. This is 3/5. 3/5 is like what decimal?
0.6.
0.6. So go to where you would think 0.6 is, maybe about right here. I'm going to say that is x equals 3/5. And let's find the two answers. There could be an answer going up right here through this point and straight down at this point. We could have an answer in those two locations. I can have an answer here, and I can have an answer here. Hey, Dulce? Okay, back over here. How do I get the x isolated? Okay. So let's go to our calculator and find the value. So trig cosine inverse of 3/5. Come on, Dulce. So 0.92 or 0.93? 0.93, I agree. Our first answer is going to be 0.93. X equals 0.93. Now that would refer to this one right here, 0.93 radians. That's that answer. Now I want you to think through you got to do a little spatial reasoning here. That's the answer going from here to here. Now the second answer is the one that goes all the way around to there. But the easier way of thinking about it is like this. How far away from this x-axis is it? The same 0.93. But that's being taken away from 2 pi. So this is 0.93 going away from 0. This is, if you went this way, 0.93 going from
2 pi minus 0.9.
That's exactly right. You take 2 pi, and this time we're going to subtract that answer. The reason we're subtracting that is because it is 0.93 away from this x-axis over here. So hit enter, and that'll give you your second value. 5.36, I agree. All right, Giovanni, what's your question?
I think you're supposed to multiply the 0.93, right, by 2. To get the actual distance.
No, what are you saying here? 5.36. Let me write that on there.
I don't know. I started with 2.
Okay, the way I got this is I'm taking 2 pi minus the 0.93. Now, where were you saying the 2 from? From the 2 pi right here?
Yeah.
So 2 pi is the distance all the way around. But I don't want the whole all the way around. I'm taking away this distance right here, but on this side. It's the same amount of distance. I'm taking away that much of the circumference. So if the circumference itself is 2 pi, that's what the circumference is. Pi is a measure of radiuses around the circle, like a circumference. I'm taking away this amount here. Well, this amount is 0.93 because if that's the amount over here, I'm taking away the same amount, but down here. That would get me all the way around the circle except for this last little section. That's all the circumference except this little part. And so that's why I'd be that answer. Here's another way you could do it. Okay, let me do it here. Here's another way of thinking about it. I'll do one more. Let's see if my board's working over here.
You try to find what this value is. The whole circle isn't.
No, are you getting this?
Perfect.
Value of this from
All right.
this axis or from this?
Another way of thinking about it.
This.
Our value was 0.93.
Whole circle is two
Okay.
pies. Because this is one. This one is two pies.
When I go that direction,
What do you got for this one?
hang on a second. When I go that direction, that's positive 0.93. You with me? I wanted to find this other one going down this way.
Oh.
Now, if I go down, that's negative 0.93. When we do this, usually we want the answers in the interval 0 to 2 pi. You can include 0, but you go all the way up to 2 pi without actually including 2 pi. That's usually where we want our interval. So negative 9.93 would not suffice. That would not work for it. So what you would do is you'd find what's called a coterminal angle. You would add a full circle. Well, how much is in a full circle? So you could add a 2 pi, and that would give you your value. Now, a second ago, the way I showed you, which that would give us the same answer. Second ago, what I showed you is to go from all the way around here. Well, that's kind of like going, if we went the whole circle, that would be 2 pi. But we don't actually go the whole circle. We miss out on this 0.93. And that's how I wrote it the first time. Those are exactly the same thing when you compare the two. It's exactly the same thing.
I thought you were going from the line, not from the axis, so that's what I'm confused.
So I was going from the positive x-axis.
Yeah.
Both times, that's why. Yeah, from the positive x-axis. All right. Let's go to example 4 here. Increases the difficulty. Let's look at some of these, so you don't get bored if you're thinking some of them are easy, maybe you're thinking them hard, I don't know, but we're gonna increase from algebra 1 to algebra 2. So now, with trig included, what would you do first to isolate this x on this problem? We add 1. So we have 4 sine squared x equals 1. What would you do second? Divide by
Very bad.
4. So sine squared x equals 1/4. Now I haven't quite isolated the sign yet, so I'm not going to pick up just yet. What would happen next? We would square root. Now here's what's tricky on this one.
Just be one.
When you square root a square, when you add a square root that's not originally there, what we don't know is this might be a positive or it could be a negative, because when you square a negative, guess what you're going to get? A positive. When you square a positive, guess what you're going to get? Don't say negative. A positive and a positive is still a positive. So regardless if x is positive or negative, you're going to end up with positive 1/4. So when you add a square root that's not originally there, unless there are other indicators to help you out, it could be positive, it could be negative. So I'm going to add that in. This cancels out. And so we're now left with sine x equals the plus or minus. We can take the square root of that. What's the square root of 1? 1. What's the square root of 4? Plus or minus 1/2. So sine, remember this is a maximum of 0, 1. Sine might be a 1/2. Sine is y. It could be a positive 1/2 or it could be a negative 1/2. How many answers could I have this time? We could have 4 possible answers. So I could have an answer here. I could have an answer, whoops. I could have an answer here. I could have an answer here. And I could have an answer there. I'm trying to draw my lines a little bit better there to see if they match up. Okay, if we're ready, let's begin. So that should cross about there, and this should cross somewhere there. We'll hit that one. Perfect. So that's honestly where the red lines should be intersecting if I was drawing it accurately. Okay, let's go use our hand trick. Oh, I didn't write this out the whole way. Let's return back. The last step, how would I get x isolated? Inverse of sine. X would equal sine inverse of positive or negative 1/2. So let's do our inverse sine. So take your hand. Which side do I look at? Back. The back. You're looking at the back of the hand. You want one sine finger. What are we bending? Ring finger? Bend your ring finger, flip your hand over. Now we're on pi side. What pi is that? Pi over 6 or pi over 3? I heard both. It's pi over 6. Since we're including all four, I know pi over 6 would work. That's this one. What pi over 6 would this be over here? It's almost 1 whole pi. That's right. It's 5 pi over 6. That's 5 pi over 6. 5 pi over 6 is the one that's almost to 1 pi. The one that's just beyond 1 pi would be 7 pi over 6. Remember, you're measuring distance around the circle. That's why it's increasing this way. You're increasing distance around the circle. It's measuring circumference. Okay. 7 pi over 6. Let me write that answer in. And finally, very good, because we are almost 2 whole pies. So on this example 4, if you're wondering what's different, this would be called, I'll just call it algebra 2. Instead of doing algebra 1, we are doing some algebra 2 here. That's the only thing different here. All right. Unless you have any questions, I'm going to move to the next. How could we do the next problem, you think? Can't combine like terms because it's a squared and not a squared on the cosines. We're going to factor it. That's exactly right. If you're going to factor, you need to set it equal to 0. This is called, to me, in my opinion, this is what makes algebra 2 totally different than algebra 1, is you learn something called the zero product property. And that is that if we can factor this, if we can set it equal to 0 and factor, we can solve each factor equal to 0. So I have it written this way, and I want you to label the values A, B, and C. We're going to do an X method here, where you do factors of A times C that add up to B. What is 6 times -2?
What?
-12, put that there. And B is a negative and no other number, so you'd put -1. So don't yell it out. I'm just going to roll through the factors. The possible factors of 12. We'll get to the positives and negatives in a moment. But it's 1 and 12, 2 and 6, 3 and 4. 1 and 12, 2 and 6, 3 and 4. We want them to be 1 apart. What do our two numbers have to be? 3 and 4. Now that we know it's 3 and 4, and I fill those in. Now let's figure out the negatives. To make it be a -1, it has to be a -4. And you can check it 3 times -4 is -12. So what does that mean for us? If you remember with factoring, if you have an A term, what's a little bit different is we're going to break this. You could go ahead if you wanted to and put a 6x first with the two numbers, 6x plus 3 and a 6x minus 4. But mathematically, we are not accurate yet because if you just think about multiplying, what's a 6 times a 6? Is it 6? Excuse me, is 6? I forgot the cosine. I'm so sorry. 6 cosine. 6 cosine. Now, if I left it like this, mathematically, it'll give us the same answers, but it's not actually the same equation because what is 6 times 6 here? 36. We need it to be 6, which means we can reduce these by a factor of 6. What can the first fraction be reduced by? 3. We could reduce both of these by a factor of 3, so I'm going to do that. And what about the second factor? What could it be reduced by? 2. So notice I am reducing by a factor of 6. It's just coming in effect by 3 and 2. Okay, so what am I actually solving? I'm going to solve 2 cosine x plus 3 times 3 cosine x.
What do you mean plus 3?
Just checking to make sure you're following. And 3 cosine x plus 2 equals. Yeah, it should be -2. Again, just making sure you're tracking along. That was a -4. That's a.
Let me take a log and say those two are
A -2. There we go. Okay, so zero product property states this. if you're multiplying and you're getting a product of 0, what's the only way to multiply and arrive with a product of 0? What's the only way mathematically you can multiply and get a product of 0, other than it's not expected? You have to be multiplying by 0. So we solve each one is equal to 0 now. So at 2 cosine x plus 1, 2 cosine x plus 1 equals 0. We're solving that. And 3 cosine x minus 2 equals 0. What will we do on this one? Well, minus 1, and then we will also we'll end up dividing by 2. So we'll divide by 2. Now that one we won't even need the calculator for. All right, I'm going to go back up here. That will provide 2 answers. Cosines which? X or Y? X. I need to go where I have an x of 1/2. X of 1/2, negative 1/2 would be right here. So the values there are going to be the intersections of the circle through that's value through 1/2 right there. So let me go ahead and now add these. I want to have these 2 answers there and here. That's x is negative 1/2. We'll come there and we'll solve that in a second. We'll solve for these x values in a moment. The inverse cosine of negative 1/2. Actually, let's just go ahead and do it now. Hand trick, back of your hand. Looking at the back of your hand, you need 1 x finger. Which finger are you bending? Index finger, flip it back over. What is that as a pi? That is a pi over 3. Now to be in the second quadrant, it's not 1 pi over 3, it is, we have 2 pi over 3, and what do we have here? 4 pi over 3. That's because 3 pi over 3 is 1 pi, which would be right there. Okay, now let's go ahead and solve this one. What would we do first? We would add 2 to both sides. So cosine 3 cosine x equals 2, and then we would need to divide by 3. So cosine x equals 2/3. So 2/3 would be somewhere in here. X equals 2/3. We will need the calculator on this one, despite what the instructions say. So we're going to look for 2/3 here, these 2 values. So we go to our calculator and we're going to type in x equals, or not the x, but cosine inverse of
Didn't it say, this is the
2/3.
they did not use.
Yeah, we need to though on this one. Okay, so we go to trig, press cosine inverse. We want 2/3.
0.84.
Perfect. So we're going to say we'll round to the nearest hundredth again, 0.84. 0.84 radians. All right, so if that's our first answer here, if we have 0.84 radians, 0.84 is that answer. How do I get this answer over here? Yeah, because it's the same amount of distance away from 0, but now we're going this way, so I'm taking away from 2 pi. So we're going to take 2 pi, and we'll subtract that previous answer. And I'm getting 5.44. 5.44. And those would be your answers. So writing them in order, I would have 0.84, which is not a requirement. 0.84. I would have 2 pi over 3. 4 pi over 3. And finally, 5.44. Now, I've shown you this is 3 different techniques I've shown you how to solve these problems today. If you remember, we first started with the graphing technique. You could graph both sides of the equation, and look for intersections. The second was using algebra, and the third was using inverse cosine. Or inverse trigonometry, I should say. Questions over what we've done so far? Hey, sine is what variable? Cosine is? Now, if tangent's y over x, that would appear like what on the unit circle? The slope, a line. Very good. All right. Let's look at examples for C and D. Okay, now let's take a look at example for C. So now let's continue solving. We have 3 tangent squared minus 1 equals 0. And so here we would need to do some opposites. So let's add 1 to both sides. And so I now have 3 tangent squared x equals positive 1. We would divide by 3. And I divide by 3. I'm left with tangent squared x equals 1/3. Okay, and so from here to isolate this tangent, we now would take a square root. Now remember, whenever we take a square root, it's not originally there, it needs to come with a plus or minus. So that would square that, cancel that out. And so now I have tangent x equals the positive or the negative, and I'm going to reduce this to 1 divided by square root 3. Now I'm not going to rationalize the denominator because this will be helpful for me. But tangent, remember, that's going to be like slope. Our slope is going to have a positive and a negative 1 over square root 3, which this number is less than 1 because square root of 3 is 1.73 roughly. So this number is going to be smaller than 1. It's a little bit bigger than a half. Excuse me, a little bit bigger than a half. So this slope is going to go up 1 over 2 approximately. So it's going to be something like this. If I mark it through, that would be the positive slope, and I'll have one very similar but negative coming through there as well. And so using our hand trick to isolate the x here, I would say I would take the tangent inverse of both the positive and the negative 1 over square root 3. So if I'm looking at the back of my hand, I need 1 y and 3 x's. So I'm bending my ring finger. So my answer is going to be whenever I have a ring finger, which that is when I bend my hand over, I'm looking at the pi side now, it would be a pi over 6, a 5 pi over 6, because this is almost 1 pi. And finally, a little bit more than 1 pi would be 7 pi over 6. And this answer would leave us with 11 pi over 6. So those would be my answers on this problem. Pi over 6, 5 pi over 6, 7 pi over 6, and finally 11 pi over 6. Those would be our answers for part C. All right, I'm going to roll through this one more time here for example 4. Now let's look at solving this problem. Now, as I look at it, I cannot just combine these like terms by subtracting 2 tangents. So what I am going to do though, I am going to subtract the 2 tangents, but unfortunately will not combine over here. So let's see what happens. This cancels out, and so what I have is a sine squared x times a tangent x minus 2 tangent x, all that equals 0. And so what we do here in algebra is I can't quite solve this, but I can't combine those terms. But what I can do is say, oh, I have a GCF. Both the front term and the back term share a tangent x. So what I'm going to do is I'm going to divide out that tangent x. So I'll do a GCF here, greatest common factor. I'm going to divide out the tangent x. This is the opposite of GCF. And so I'm left with a sine squared x. When I take that out, minus 2 equals 0. Like that. So now I have what we would call a zero product property. A zero product property, algebra 2 tells you if you are multiplying, there's only one way to multiply and get a product of 0, and that is to multiply by 0. And so I can solve each one individually now. I could say tangent x equals 0, or sine squared x minus 2 would equal 0. Now this one's easy. To have a tangent of 0, I need to have a y of 0. So if you flip your hands upside down here, I do an inverse here. And so if we're looking at the back of our hand, I need 0 y's, which means I'm bending my pinky. And so the answer would be 0. So we have a tangent of 0 here at 0. 2 pi could also be an answer, but we're going to limit it between 0 and 2 pi. We won't include 2 pi. So we'd have an answer at 0. And I'd also have the other place we'd have a pinky is at 1 pi. And so this value would be 0 and then 1 pi. Those are 2 answers. Now over here, these aren't going to be any answers at all, because when I add 2, what we're going to find out here in a second is I'm going to be taking the sine squared x of 2. When I take the square root of both sides, we need to have a plus or minus here. It'll be the sine x of plus or minus square root 2. That number's too big when I go to do a inverse, sine inverse, and actually I shouldn't say x equals. If I just wrote down sine inverse, positive and negative square root 2 does not exist, because it's outside the restricted domain. For sine inverse, the domains be all values between -1 and 1. So this does not exist. There is no other answers. These should be my only 2 answers on this particular problem. And we could go graph this just to check it out. So I'm going over to graph here, and I want to graph my sine squared. And this is sine squared is a little tricky. I don't know if I've shown you this in the calculator. You have to put the square in the outside of the parentheses like that. So it's going to be sine squared, whoops, times tangent of x. That's one equation. And then I'm going to set that equal to 2 tangent x. 2 tangent x. Press enter. Now I'm going to look for answers here. And we're going to see that the answers we have, let's go menu, analyze graph. Intersections of these 2 graphs. You'll see we have an answer here at 0. I'll have another one, hopefully at pi. That would mean I did it right. Analyze graph, intersection. We could see this answer will be at 3.14. And then let me move these equations out of the way. And if I tried one more, analyze graph, intersection, you'll see the next one's at 2 pi. And so every answer comes on a period of 1 pi. So we did do this correctly. How about that? So with this, you can get started now with your DOL. DOL number 4. All right, now let's take a look at example 5. So on example 5, we're still solving. Everything's the same except for now I'm going to have some transformations going on in the inside. I'm going to show you how that works. Okay, so let's begin again going through our same steps we've been going through. What would you do first to isolate the tangent? Well, answer, it's already isolated. This one's already isolated. This is telling you the slope of the line is going to be the square root of 3. Tangent is slope. It's going to be the square root of 3. It appears right now. So what you would do is you'd say, okay, that is a positive slope. So I'm going to take a positive slope, a slope of square root of 3 over 1. That's how it's appearing. And I'm going to draw it. Let's just say it looks like that. Okay, so that needs to go up 1.73 for every one it goes over. Let's just say it looks like that. Now, how would I isolate this 2x on this inside? No, I can't divide by 2. It's inside a tangent.
Would you do a reciprocal tangent?
No,
We just
we don't do cotangent yet. What do you do to get this 2x isolated?
inverse.
Inverse. So when I take an inverse, I now have tangent 2x equals tangent inverse of square root of 3. Okay, so now to solve this, I'm gonna first find this and then we'll do I'm gonna reduce the tangent inverse and then we'll come back to that. Once you take your hand trick, if it's the inverse, which side of the hand are we looking at? Back side, so flip your back hand over. We want tangent, which is y over x. To help us out here, I'm gonna put this divided by square root 1, because that doesn't change it. It's like dividing by 1. You need 3 y fingers and 1 x finger. Which one are you bending? Index. Take your index, flip it back over. That's a pi over 3. That means this answer is at pi over 3. What's this answer down here? 4 pi over 3, because so I'm gonna have to write this twice. Because I'll just write it out one time as a comma. After this, I'll just write it twice. Because that's beyond 1 whole pi. So we got pi over 3, 4 pi over 3. Now, 2x is going to equal those two spots. So how do I solve that? What do I do? It's going to be divided by 2. So x is going to equal pi over 3 divided by 2. And x is going to equal 4 pi over 3 divided by 2.
So multiply.
It will. So when you divide by 3 and then divide by 2, that's the same thing as dividing by 6. So our answers become pi over 6 and pi over 6 and 4 pi over 6, which could reduce to become 2 pi over 3. Those are my two answers. Now, did that appear in the same spot as my line did?
No.
No. That's because what we did is, if you think about it, we cut the angle in half. Now, why did I cut my angle in half? Because it's on the inside, and inside's a liar. So instead of doubling the angle, what did I actually do? I cut it in half. And so 4 pi over 3 became 2 pi over 3. 1 pi over 3 became pi over 6. They got cut in half. All right, let's try this one. Let's reload and do part B. By the way, it says to check it on the graph. I'm going to do that. I'm going to add a page. Go to graph. The way you would graph this is you would just type in the original function, the left-hand side. So true tangent x. I'm graphing that. And then I would graph square root of 3. Now, I would only be looking on the interval. It says take only answers from 0 to 2 pi over 3. So just to make sure I can see the y-axis, I'm going to do negative 0.1. And this, the answer to 2 pi. 2 pi. And I want to make sure I can see just past 2 pi, so I'll do a plus 0.1. Okay, so here would be my answers according to the calculator. And why am I getting so many more than I think I should be? Intersection of these two graphs. Check to see if that's pi over 6. Menu. Oh, I know why we have so many more. Here's why we have some more. Those are the first two we found. Because when you divide the angles by 2, all of these get divided. So we've actually only approached 1 pi. So I need to stop here. I'm going to say this again. You see how we divide this by 2? Everything gets divided by 2. So this gets divided by 2. And so when I've gone around, I've only gone around to 1 pi. I would do this a second time. So I would need to add a pi to this and add a pi to that. So let me go ahead and write this out. What I'm trying to say. I would also have pi over 6 plus a whole pi, that's a period. And I would have a 2 pi over 3 plus a pi. So before I say that's my answer, I'm glad we went to the calculator to check this. What would our final answers be? Well, it'd be pi over 6, 2 pi over 3. What's 1 pi over 6 plus another pi? 7 pi over 6. It's the pi over 6 that's right after 1 whole pi. And then what's 2 pi over 3 plus pi? 5 pi over 3. Those are going to be our 4 answers. And you can confirm that by doing the graph. Those are the values there. That's where the intersections are. Let's look at part B here. If we were to solve this one, what would you do first? Subtract 1. So when I subtract 1 here, I have 2 sine x over 3 equals -1. Now what?
Divided by
Say
two.
what? Divide by 2. Now at this stage, I can state that sine of x over 3 equals 1/2. Now I can move over to my unit circle. Sine is what variable? Y. So I'm going to be looking for y's to have a -1/2, which is like right in here. I'm going to take the values that have a y of -1/2. So what are those two angles that have those? Well, we can do that with an inverse sine, which I'm gonna, once I write this out, we'll find those. So continuing on to isolate, how would I isolate the x over 3? Is I would take a inverse. So x over 3 would equal the sine inverse of -1/2. Okay, so hand trick. Hand trick, look at the back of your hand. What finger do we bend to get a sine of just a square root of 1 over 2? Which finger would you bend?
The ring finger.
Ring finger. Okay, now I know it's negative, but for the hand trick, you still do the same thing. Ring finger. Flip it back over. What is the ring finger in terms of pi? It's a pi over 6. So both of these are pi over 6s. Which pi over 6s are they then?
7 times 6.
This is 7 pi over 6.
Yeah, that's pi over 6.
This will be 11 pi over 6. So x over 3 would equal 7 pi over 6 and 11 pi over 6. But we're not done yet. What do we need to do to actually get our final answers?
Multiply by 3.
Multiply by 3, which means I would need to change the domain to get my answer, because this is not going to stay in between 0 and 2 pi. So when I multiply by 3, I get 21 over, that can actually reduce. 3 goes into 6 how many times? 2 times. So it's 7 pi over 2. And then this would become 11 pi over 2. And I know we're running out of time. So our interval has now changed. This would be on the interval from 0 all the way up to multiply 2 pi times 3.
6.
6 pi. These are the solutions between 0 and 6 pi. There they are. That would be the solutions there. Let me add that in on 0, 6 pi. All right, now let's take a look at example 6. It says find an interval that'll satisfy the inequality on 0 to 2 pi. So this time what we're going to do different is we're going to solve the same way. So I already have this isolated. I want to know where cosine is greater than 0. So I'm going to do the same thing we've done before. Is I'm going to say, well, this would be saying that 2x is greater than the opposite of a cosine function is an inverse cosine. Cosine inverse of 0. Well, cosine inverse of 0, that means you have x 0 fingers. So if you flip your hand back upside down, you have x cosine, you need to bend your thumb when you flip it back over. The thumb represents pi over 2. This is a spot where we have an x of 0. Remember that spot right there is the value. Let me put pi over 2 in the inside. Pi over 2 is a spot in the unit circle where we have a value 0, 1. And we'd also have 3 pi over 2 down here. That would be 0, -1. And so what we just now can substitute in is we can say that 2x has to be greater than pi over 2. Has to be greater than pi over 2. And now for this second answer, because we're going to come all the way around, we're going to find out that it has to be in between 3 pi over 2. And I'm going to kind of show you this visually. So I'm going to go to my graph real quick just to show you this. This would be easier to show you on like a Desmos, but I'm going to show you here for now. If I graph this cosine, cosine 2x, and I want to know specifically where it's greater than 0. Let me blow this up so you can see a little better. I can see that it's greater than 0 along this part. And you know what? Let me come over here. This is the spots where it'd be equal to 0. I'm sorry, where would cosine be greater than 0? Well, cosine is x, so it's greater than 0 from here to here, like that area. And also, when we come all the way around, it's going to be greater than 0 over here. Since it's greater than 0, let me do from 0 to 2 pi. So 2 pi, when we come back around, it's going to be an open circle on this side. But 0 to pi over 2, since we got to be greater than, I'm going to do an open circle. And then this will also be an open circle. We'll pick back up 3 pi over 2. This would be the interval without a transformation. So as I do this, I'm looking at my math here. I would need to change something. Mathematically speaking, for this to be true, what we'd have is 2x is going to be less than, just for a moment, I'm going to just do a squiggly line here. 2x would have to be less than pi over 2, because it's got to be in between here. And then we'd also have another interval to solve where 2x is greater than 3 pi over 2. Now, why am I saying that? Because x, cosine is x, and we need to be on the right side of those two values. So to be on the right side of pi over 2, I would need to have 2x less than pi over 2. That would get me over here. And then on this interval from 3 pi over 2, I need to be greater than 3 pi over 2, but less than 2 pi. And so honestly, if I wanted to plug in an interval on both sides, let me write it one more time. Here we go. What I'm going to do is erase this just for a moment. Is this interval is from 0 to 2, like this. 2x is from 0 to pi over 2. That's that interval. The second interval that provides solutions is from 3 pi over 2, which is less than 2x, all the way up to 2 pi, not including 2 pi. And so the last thing to do on both of these to get our solution is we would divide by 2. Now, if you divide, division works like multiplication, you have to distribute all the way through. So everything here is going to get divided by 2. That means for this interval, we'll have that 0 is less than 1x, which is less than pi over, now that was pi divided by 2 again would be pi divided by 4. And the other interval, I should say, or the other interval would be 3 pi divided by 2 is divided by 4, which is less than x, which would be less than 1 pi. So I've changed my inequality. So now it would be for here, how about find the interval that will satisfy the inequality on about 1 cycle? Because this is no longer on 2 pi, this is only going up to 1 pi, because you would divide everything here by 2. And so this would be our answer here. So let me go back over now that we have it, to this calculator, and I'll show you. So if I look at the intersection, this value right here is going to be menu, analyze graph. If I chose intersection, this area from here to here. Okay, why is it not clicking? Let's see here. Well, my calculator is not functioning with me, so I'm not going to be able to show you here. But you would go from this point, there it goes, to there. That value right there is going to be pi over 4. Control doc. Let me show you. Graph calculator. Pi divided by 4. That's what that value is going to be. Pi divided by, well, my stuff's tripping right now. Pi divided by 4. 0.785. You look over here, that's 0.785. And then it would pick back up, menu, analyze graph, intersection from here. No, that's not what I wanted. I'll have to fix that now. Trying to get these graphs out of the way. Let me blow it up again. There we go. This was f of x equals 0. Well, goodness gracious. Why isn't it cooperating? Here we go. Well, this is just getting frustrating now. Okay, so I finally got my graphs fixed. So for one cycle from here to here, you notice from 0 to pi over 4, that's what that value was, pi over 4. And then this value here, I've forgotten what it was. I think it's 3 pi over 4 up until pi, which would complete one whole cycle. That would be the part that's above 0. And then we'd repeat. This would be from 1 pi to 5 pi over 4. And then this would pick up at 3 pi over 2 and go up to, excuse me, that would be 7 pi over 4 all the way up until 2 pi. And so that's how that value would work. All right, so back over here in example 6 to finish this up. What about here? Sine x minus pi over 3 is greater than or equal to sine. Now this one's a little bit trickier. What it's saying is for any angle, we want to know where, let's just pick any angle. Let's just say we pick 0. Where is this sine function going to be greater than this one? Well, what that happens on this one is you would plug in a 0 and subtract pi over 3, which means this one, I'll do this one in green. This one, let's do this side in green. And this value of sine, we're going to do in red. Okay, so if this is 0, this value would be down at 0 minus pi over 3, which is negative pi over 3. Okay, so this value would be placed, negative pi over 3 is about right there. And so they're always going to have this distance apart. This distance from here to here will be the distance of these points as we move along. So if I chose any point along, let's say I went up here and I moved beyond 0. I'll put the 0 back here. This is 2 pi. And this is pi. This is pi over 2. This is 3 pi over 2. If I started moving along, what I would need to do is take that point and rotate this if it'll let me. I don't know if it will. Yeah, it's somewhat working there. You would rotate around, and so this value would be here. So when we get to positive 3 pi over 2, I'm sorry, pi over 3, when this red point becomes at pi over 3, that's just not wanting to cooperate there. When that value gets to pi over 3, well, the green is now at 0. But notice the sign is still less than. So that none of these would work. What we'd have to get to is a point on the circle where the red is so much further away that these 2 points are now equal. So it would start here, which is actually going to be 1 pi over 3. And it would continue on as long as it's over here because sine is y. So as long as the green's above the red, we'd be good. And it would be good from all the way over here where they were equal to each other. So from this point here, when they were equal to each other, when these 2 points were equal from here to here. And it would stay good along the interval all the way up, and the red's going to determine the interval, by the way, until we come around to this point here. Until that value there, which is the pi over 3 in the fourth quadrant, that would be a, not a 7 pi over 3, I'm sorry, a 5 pi over 3. Now that would be the value, and this over here, if you're wondering, would be 4 pi over 3. And on these two, this was pi over 3, and this is 2 pi over 3. Now how did I know that? Because they're pi over 3 apart. And so that's the values. So we're good from this point. Let me put the green on here again. We're good on the interval from here all the way around to there. So that's how I could solve this. Looking at a graph, that would be my interval. So from anywhere from 2 pi over 3, which is less than x, which is less than 5 pi over 3. That would be my answer on this one. Now we could graph these as well. And this time I'm just going to do a graph to show you. Maybe I will. Let's see here if it'll graph if I clear the document. All right, so graph. We're going to do this time, there is an inequality. Let me see if the inequality works well. How about this? No, it's not going to work. So let's go with sine x minus pi over 3. Pi over 3. And we want to know when this first graph is higher than the second graph, greater than or equal to sine of pi over 3. And we're going to be looking between on one cycle. So again, when is not pi over 3? That's supposed to be just be an x. What am I doing? There we go. We want to know when is the blue graph greater than or equal to the red graph, meaning above it? So it's not up in here, it's this starting at this value, menu, analyze graph, and intersection. It would be from this point here. No, I'm changing the graph, that's not good. From this point there, and I need to change this back. All the way until this point down here, analyze graph, the blue stays above until this point right here. And you can type in the values, and you see that that is exactly what we found just a moment ago. So with that, I'm gonna let you, oh, never mind, I'm getting ahead of myself here. So let me work a couple more here. So with inequalities, how I'm gonna do is I'm gonna use or here. So let's subtract 1 from both sides. I subtract 1 from both sides. I have 3 cosines is greater than or equal to -1. And now when I divide by 3, I divide by 3. I get that cosine x is greater than or equal to -1/3. Now I want you to think about this. Cosine is the x value. So if I went to -1/3, which just states right there, that's x equals -1/3. My answer is going to be, that's so ugly. Let me try that one more time. 1/3. There we go. My answer is going to be all the values, because a cosine being greater than or equal to, it's going to be all the values to the right of these 2 points. And we would include these 2 points. So all this interval is acceptable. So all this interval is acceptable. Now the question could be, what is that interval? What is that interval? And so that's where we'd have to go to the calculator and find out the value. I'm going to take x for a moment. I'm just going to do approximately for the calculator. Goodness gracious, come on. Approximately, let's see, cosine inverse of -1 divided by 3. I close my parentheses here, get good math. So if I go back to my calculator, for some reason it's just not working when it's on the side screen. And so when I come over here to calculator, I want to type in the cosine inverse. So trig cosine inverse of -1 divided by 3. And that gives me 1.91. So I'm going to take 1.91 back over. And I also need to find the other values. So as I take this back over, you notice I take 2 pi and subtract by 1.91. Here's why. 1.91 is from 0 to this point, 1.91 radians. Now I would also need this point over back to 2 pi. And so taking away from 2 pi, you get this as 4.37. So my interval here is from 0 is less than x, less than or equal to, I should say, which is less than or equal to 1.91, or x can be between 4.37, which is less than x, which is less than or equal to 2 pi. Okay, one last time. Let's talk about how we solve this. With an absolute value, what do? Well, we'd add 1 to both sides. And so now we have that for absolute value of tangent x is going to be less than 1. We would divide by 4. Now there's an algebra rule that when you have an absolute value isolated, that you solve it one of 2 ways. One way is that when we solve this, first we're going to get what the value is for tangent. We're going to have to, in a second, flip around this inequality. So first, if I just went and grabbed, let's see, what is tangent inverse of 1/4? I'm going to go over to my calculator and see if it cooperates with me. Actually, I don't think it will, so I'm going to just go ahead here. So what I'm going to do is hit trig tangent inverse 1/4. 1 divided by 4. Now that I have that value, in a second, tangent usually works with a pi. So I'm going to hit pi plus this value. And in a second, we may also need pi minus that value. So I'm gonna just go find them all while I'm here, since my calculator is just not cooperating very well. And I also might need 2 pi minus that value. So I'm just gonna get them all, and then we'll interpret what it is we actually need in a moment. So I'll have all my answers together in one slide. Okay, so now I'm gonna go back over and let's take a look. So here's what we have. We know tangent, that's slope, is 1/4. The absolute value of tangent would have a slope of 1/4. Well, that can mean it could have a positive slope of 1/4, of 1/4. Or it could technically be a negative tangent of 1/4. Now here's the deal. We could be 1/4 or smaller. And if it's absolute value, you could only go down to 0. You couldn't get down to the negative values. So tangent, or actually it could be anywhere from 1/4 to negative 1/4. We could have an answer anywhere in this interval in here, or in this interval here. Because tangent could not be greater than 1/4 of a slope, but it could be smaller. It could be a 0 slope. It could be whatever. So it could be flat, something like that. So anywhere in there, in this area, and anywhere going down, because that when you take an absolute value of it, it would turn it positive, and so it could be anywhere in this area either as well. So writing in these values, the calculator says this is 0.24. This value, that would be pi minus, here's pi, this would be pi minus, which was 2.90. This value would be pi plus, we're gonna need that, it's 3.39. And then this value is 2 pi minus, that's going to be the 6.04. So our intervals here would be 0 is less than or equal to x, which is less than or equal to 0.24, or 2.90, whoops, 2.90 is less than x, which is less than 3.39, or one more interval, 6.04 is less than x, which is less than 2 pi. And that would be the answer for part B. So there's a whole lot there. DOL number 3, I'll let you work on this, and you can use a calculator if necessary. All right, now let's take a look at example 7. It says, when breathing, a normal cycle takes place every 5 seconds. Velocity of airflow is modeled by this equation, where y is measured in liters per second. Velocity of airflow is positive when we inhale and negative when we exhale. For one cycle of breathing, find an interval of time where this is greater than 0.3. Okay, so again, we can walk through using a calculator, but if I did my algebra, what I'll do here first is I notice this is multiplying. So if I take this and divide by 0.6, I need to divide on both sides. What I get is that sine of 2 pi over 5x has to be greater than or equal to, that's going to be 1/2. So in a unit circle, what are the values where sine is greater than 1/2? Well, sine is y, so we're looking at the values, if this is 1/2, we're looking at the values that would intersect those two spots. Specifically, if this needs to be greater than 1/2, we're looking at this interval. Now, if I use my my hand trick, I can find out that 2 pi over 5x is got it. I'm going to compare it to, for a second, the inverse sine of 1/2, which the calculator, or if you did a hand trick, take your hand upside down, flip it, you bend your ring finger, you flip it back, you're going to get a pi over 6. So what we have here, looking at this, if this is pi over 6, this is going to be 5 pi over 6 because it's almost 1 pi. What I'm going to say is my values has to be in between those two values. So pi over 6 is going to be less than or equal to 2 pi over 5, which is less than or equal to 5 pi over 6. And I forgot my x. Oh no, let's get that x in there. Less than or equal to 5 pi over 6. And so to solve this, what I'm going to do is multiply by the reciprocal at 2 pi over 5. I'm going to multiply everything by 5 over 2 pi. If I do that, and here 5 over 2 pi, and here in the center, these will just simplify because those will, when I multiply that out, that will get canceled. And so what do I find? The interval of time, it would look like this. Well, pi's cancel out with one another. So it'll be 5 over 12 seconds, which is less than or equal to x, or I should use t, but I'll just use x because that's what the equation is, which is less than or equal to, again, over here, those cancel, 25 over 12. So from approximately half a second to 2 seconds, approximately, that's where we're breathing in air faster than 0.03 milliliters per second. That's the context. From time, whoops, where'd the other, my m go? Time, 5/12 of a second to 25/12 seconds. From time t equals, or x equals 5/12 of a second to 25 seconds of 25 or 12 seconds, we are inhaling at least 0.3 liters per second of air. That's what that means in context. So now that you've seen me try and apply this, I'll let you do your DOL. DOL number 4.